What's going on, everybody? I'm Alexander Williamson, and you are watching FISHTORY. So, what today's video is on the impacts of sound on our fishy friends. So, I was recently on New Year's Day with my wife at a music venue, and they were playing loud music, and in this venue they had a 1,200-gallon aquarium with beautiful koi in it. And, well, here, I'll just show you. So, these beautiful koi, I thought, there's no way they're happy with the sounds going on in this basement. And I thought, you know, I got to get home and research this and see if this is a problem for these fish. And it turns out, sure enough, that yes, carp are actually in the cyprinid group, which happens to be one of the worst groups to be impacted by sound. Like, they're very, very sensitive to sound, more so than any other group of freshwater fish. But beyond that, I had people messaging me all through the early part of this year, you wonderful members, you, asking, hey, I vacuum near my fish tank and my fish all disappear. Or when I put music on, my fish come out. Is it good? Is it bad? What's going on? And so it made me think, okay, I gotta figure out more about this. I gotta do a deep dive, and thanks to all of you and your support of the channel, always giving thumbs up, and, you know, all you subscribers and all you members, you know, I can do that. And so I've spent the last few weeks researching this, and the last few days really intensively. And so in this video today, we're going to talk about, okay, what is sound? And really briefly, we'll talk about what sound is underwater, in air, how it impacts human ears and how we evolved to hear versus how fish hear, which, by the way, fish have 3 ears. It's kind of a wild story, and you can't see any of them. And then beyond that, we're going to talk also about what the impact is on fish. Not just fish out in the wild, because I got home and I was looking for papers on the internet about, okay, what are the impacts of sound on fish, and does it stress them out? Does loud noises stress fish, basically? And it turns out that yes, very loud decibels of noise will damage a fish's hearing physically. However, what was more interesting was all the papers written about the behavioral changes and neurological changes fish have to sound, which is just pressure waves in water essentially, and how low frequency, low volume actually has a bigger impact on the fish's existence. So there are many fish out in the wild right now that are dying, literally millions a year, because of anthropogenic or human-made sound from things like submarines, boats, construction, building bridges, things like that. And it's been studied heavily. Over 100 papers have also been written just on sound impacts on the species in our aquariums. So we're going to talk about all of this, and because you've seen my face plenty of times, we're going to look at video of fish and all sorts of graphics about sound today, and we're going to get to the bottom of, should you play music for your fish when you're out of town? Is it good or bad? Does it hurt their hearing? And what types of sound are killing fish? We know the loud, really loud, you know, booms of warships and nuclear submarines and things like that. We know that can damage fish's hearing and physically damage their body because of the compression waves going on there. However, what is more unexpected is what we've learned in the last 5 or 6 years, which is that low frequency, low sound level, or low volume level rather, low decibels, it is having a major impact and killing fish due to stress, due to starvation, and due to not reproducing. And that directly has an impact on our aquariums and the kind of fish we keep. So, since you've seen enough of me, we're going to look at the fish and we're going to talk about the sound. So get ready and let's jump in. Now, before we can talk about the amazing adaptations and evolution that have gone on inside of fish for them to use sound and vibrations as a way to literally see and feel the world around them in a way that is far more complex than we use sound, we need to talk a little bit about what it is exactly that sound is, and also we need to talk about some human reference points so we know kind of where we're coming from. And This will all help explain in the end whether our fish would prefer listen to K-pop and classical music and how loud, or whether the vacuum cleaner or a hair dryer or even the pump on their tank may actually cause them stress. Now, as I mentioned, we've known for a long time that sudden loud sounds, we think of those in more common terms as a shock wave. So something like an explosion underwater, or even an explosion above water out in the atmosphere where we are, that can rupture an eardrum. And that's because sound is made of energy. And sound is made of energy in wave format. And each wave has an amplitude or a height at the top of the wave and a bottom at the bottom of the wave. So it has a size, and that size is equal to how much energy it is moving. And then it has a frequency, and we measure these frequencies in hertz. Now, hertz are how many of those waves from top to bottom, and then again top to bottom, are going on in a certain amount of time. So for instance, if you had a wave of sound coming out of a speaker and there were 3 of those waves playing every second, that would be 3 hertz. If you had 10,000 of those waves being played, that would be 10,000 hertz. And we call that high frequency versus low frequency sound. Now, low frequency sound can have a lot of energy. You can still have 100 decibel sound wave that's only 2 or 3 hertz, but humans wouldn't hear that. It would be something like whales or elephants or fish, in some cases, would be able to hear. Whereas to the higher end of the spectrum, humans can hear about from 0 to 20,000 hertz. And we've kind of created this scale to match for humans. So anywhere from 0 to 20 is where your average adult can start hearing the hertz or picking up a high-pitched frequency when they do those hearing tests and you hear the high-pitch buzz or ringing. Well, that is a very high frequency noise, probably 20,000 hertz or something like 15,000 hertz. And over time, we can get damage to our ears and lose that ability. But if you have that same scale, fish are only able to pick up a much smaller section of it. And because they only pick up a much smaller section of it, they actually have a whole lot of tricks up their sleeve with how they evolved to deal with it. But let's finish up talking about sound. And so sound moving through the air, those waves are measured in decibels. And so when we say the volume was intense, it was a loud sound, we can know that that was a lot of energy moving. Now, just like I said, in an explosion, you've got a big shock wave moving, but it may have a very low frequency. It may be very bass oriented, like sound like a thud of a drum. And just like a drum, it's moving air out of its way. Well, underwater, it's also moving molecules, and it's like dominoes, and it's the sound wave hits those molecules and they hit the next one and hit the next one. So as soon as sound hits water, you actually lose about 60 decibels right off the top. And how many decibels are there? Why do we call them decibels? Well, decibels are just a unit of sound, just like we have the hertz, which is the frequency of sound, basically within a human range. And then we had to extend that later for other uses. Just like there's a visible range of light, there's also decibels, and we basically use that for human hearing. So 0 to around 150 to 180 decibels is where humans hear. Now, hertz are measured evenly. So every unit of a hertz is per second. So you've got however many waves per second, and it goes up nice and linearly on a graph. But when you look at decibels, they're like earthquake charts or like pH scales. They are a logarithmic scale. And so 10 decibels is equal to 10 units of, say, air if we're in the atmosphere on Earth here as humans. Well, 20 decibels is 10 times as much. And 30 decibels is 10 times as much as that. and 40 10 times as much as that. So soon you're 1,000,000 times more intense in power by the time you get up several units of 10 in decibels. So it is a exponential curve, and that's done because there's so much energy in the universe, and even as humans we can hear those sound waves when they are produced by things that create a lot of a thud, that move a lot of air. If it's far away, we can still hear these things. Creatures like whales also can hear these deep sounds, and fish in fact can hear deep sounds, which are usually very low frequency, and generally they're going to be high decibel for humans to hear. But for fish, they can hear something that would be 100 decibels up in the atmosphere. As soon as that hits the water, it drops that 60 decibels on average, because water is so much harder to move through, and it absorbs energy almost like a brick wall. Just like if you make 100 decibel noise on land and it hits a brick wall or a stone wall, it's going to drop something like 90 decibels. It's going to very slowly move through that. But the amount of those molecules that it does move, it will shatter, because that is not a movable substance. That's a solid. And so rather than it reverberating through the solid, only certain notes will come through that solid substance. And due to the wonder of nature, fish actually have something solid inside of them to act as that brick wall, so to speak. And we actually have something like this in evolution, where fish have something called an otolith, and it's used for other things as well, but it is a solid stone of sorts in the fish, so that they can hear really high energy sounds that are out of their decibel range possibly, but out of their frequency range. So just because fish hear from 0 to 2,000 hertz generally, and humans can hear all the way from 0 to 20,000 hertz, they've evolved a clever way around that. So it doesn't always translate 1-to-1 for the decibels or hertz, and there's not an easy conversion rate for fish. So we simply have to study each species one at a time, and then assume that the similarly evolved species that have similar anatomy of their ears and their lateral lines and air bladder, which now I've tipped you off to where we're going next, which is the anatomy of hearing in fish. Now that we understand what sound is and how it's working, fish have evolved all these sensory organs all over their body, and most of them have to do with vibrations. And in their inner ear, they have a piece of solid material that is going to allow them to transfer very high energy and high frequency sounds into a lower range as it moves through that. But they also have, in many fish, a swim bladder. So in fish like cyprinids and goldfish, carp, little tetras and barbs, things like that, minnows, they actually have what we call a swim bladder or an air bladder, and it's filled with atmospheric gases. So it is able to understand another range that's outside of their normal water hearing. And then there's also a part of their ear that picks up the actual sound waves moving directly through water. So just like in the human ear, there's an opening that hears sound moving through the media that we live in. There is, in the human ear, there is our ear opening and the main opening entrance, and all that apparatus is designed to funnel sound into one little canal, essentially. And that sound enters through one canal and also hits a membrane and moves like a drum, in which these little tiny hairs, they're called cilia, then can sense how much that drum was moving back and forth, and that in turn is what sound is made out of. It is how many of those waves hit that drum in our ear, how hard. Now beyond this, we also have another set of organs in our ear that are designed to hit the eardrum separately and then go to the cochlea, which is another apparatus in our ear and has organs in it that is full of liquids. And so in the same way that fish are using a trick of having different medias of sound waves to move through, humans actually use this same trick. So just as humans have a ear canal and inner ear that has liquid and gel in it, which allows us to pick up a different array of sounds and frequencies, decibels and frequencies, this allows fish to do the same when they have air in their swim bladder. So they have air and a solid, whereas we only have air, water, and that's it. They have air, water, and a solid to transform and send signals in many fish. Now beyond that, they have another organ called the lateral line in many fish. The lateral line is an absolutely incredible organ on fish. It is a strip of nerves and sensors all down the side of many fish. Not all fish, but many fish, including most of the fish we have in our aquarium hobby, have a lateral line. Now some of them are what we call broken lateral lines, where there's kind of two different pieces. Some of them are continuous. But either way, they have a line of little pores that allow water to move in and out of these little sensors, and then that pushes on these little gel-coated cell membranes that then have little cilias, just like in an ear, on them. And not only do they hear from one specific direction, like a human ear, each of our human ears hear from one direction, and they focus and amplify sound so that we can kind of focus in just like our eyes do. We have two eyes so that we have binocular vision, while we have stereo hearing because of having two ears. And fish actually have three ears essentially, and they have extra organs to pick up the sounds in their actual ears, which are hidden. So you don't see ears on a fish. They're tucked away in the body, of course, but the lateral line and the swim bladder are both extra sensory organs that they have that humans don't have an equivalent to, really. So while we may be able to tell that there's pressure coming from the left, if it was a really big blast of energy, like, 200 decibels of sound of bass, low frequency, a fish can tell if that's 3 or 4 hertz and only 10 decibels. And it can tell that energy, where it's coming from, and how fast each wave landed on that organ, in which order. And it has that lateral line on both sides. On top of all that, it has its hearing. So it's basically got 3 different points to figure out which way something's coming from. And this is why fish are creatures that rely so much on these organs, why sound and vibration are actually part of their visual cortex as well. It actually maps out in the brains of a lot of fish, just like sonar does for bats or underwater cetaceans, things like whales or dolphins. There's actually like a sonar system for fish with our hearing range set of sounds and pressures. So just because they only hear 0 to 500 in the case of goldfish hertz, that doesn't mean that they're super limited and they just can't hear any of those other sounds at all. They have ways of picking up those other sounds. We just don't know how their body interprets that, because in nature there's very different kinds of waves. There's waves that are definitely a big force, like a splash or tidal motion or wind on a lake or river and currents. And that's one very common, consistent form with a lot of energy to it. So fish don't even bother with that high decibel energy sound because they're feeling it on their sides. They're feeling it with their lateral line and with their skin even too. And if they're catfish, they even have onodontodes or whiskers that sense it. And they even have taste buds all over their body to taste what's going on around them. Up to several thousand taste buds on their body in Loricariidae fish in particular, so plecos and catfish like Corydoras. So all these senses have made fish obviously sensitive, and they hear sounds like human sounds, and like I said, the big ones can still cause damage because they're enough energy that they can literally bruise or rip tissue. However, where we overlooked it for so long, and only in the last decade do these very important studies show that things like migration that may depend on tides, or it may depend on how much algae is in the water, and maybe they're using the frequencies of the ambient sound in a river, and they're figuring out how much of that sound is blocked by each little microcrustacean in the water, and that's painting a picture for them. And without it, they can't figure out where their food is. And so we've noticed everything from failed mating behavior to failed attempts at catching prey, being, off by several inches when they try to make a strike at something that moved in the water, and avoiding prey. So this causes a lot of fish to die just from confusion and stress. Now, beyond all of this, the part that's more applicable to our fish in our aquariums, I would say, is the fact that these sounds are stressful. They create cortisols, which are a hormone in fish that then releases things like adrenaline and causes their heart to beat faster. So wild-caught fish in studies were found to still be very, very reactive to any sounds they could hear, any vibrations that are not just strictly in the natural world. And even if it is in the natural world, they may still react because in the natural world, that may be the sound of an eagle splashing down to grab a fish. So when we have fish from the wild, their senses are intact and they haven't gotten used to the sounds of captivity. So in captivity, we've studied fish for many, many years. That's how we usually studied them for the last 150 years. In fact, in the 1960s, we were able to figure out all these things like the lateral line and the rest of the fish by keeping fish in captivity and hooking up electrodes to their actual organs or to their exterior. But in many cases, we actually did surgeries and hooked wires right up to the fish and could see electrical impulses being created by those organs, and they were being sent up the spinal column to the fish's brain, and then from the brain, obviously, they're sent to the fish's muscle tissues and things and say, swim away, or dive down, or flex, or pull your blood towards the core, towards your organs. And that's what things like adrenaline and epinephrine do. And that's why when a fish gets scared, somebody pounds on the glass or something, that may not be a frequency that is damaging to the fish at all. It's just stressful. It's like living in a war zone. And just like a human, fish can't tolerate being bombarded by things that they think are potentially coming to kill them all day long. And so fish that are born in captivity, they don't respond at all the same as fish that are caught in the wild and then brought to captivity. Now, depending on the species, and they've done studies on over 100 different common aquarium species, depending on the species, some of these species, it's not that big of a deal. They get used to captivity after a month or two, and eventually they'll come out if it's quiet or, if all is well. However, there's other fish like ghost knife fish or like elephant nose mormyrids that have electrical systems beyond all of this. And so they're also playing with electrical fields and things on top of all this that can throw them off. And what they're finding now in more recent research is that not only did fish not want to reproduce or catch food or stay in areas where human-made sounds were coming from, but they couldn't function. There were some fish that they noticed couldn't even swim straight. So fish that would normally swim, you know, from point A to point B in a relatively straight line with a fish flexing in an S pattern, they would see that it would flex its tail wildly to one side, and then again it would spasm to that same side, and then maybe it would swim in a circle, or it would dart to the left, then to the right, then to, you know, the left again. And so they're seeing these crazy erratic behaviors in the wild fish. However, the fish that are born with these sounds consistently going on, that are within their hearing threshold, are more used to it. So the question for us becomes, what is humane to our fish? How much do we think our fish feel? And you can do this simply by watching your fish and noting how each species responds and knowing where your fish come from. That's why I really like to support good suppliers that tell us, are they wild caught? Are they raised in a fish room? If they're raised in a fish room, then that artificial sound of a pump or a linear air piston is not going to be so annoying. Whereas even though that's a low decibel noise, it can be very quiet, it's a hum that's all day long in the water. And while those are less distracting to fish, because eventually they'll, even if they're wild fish, they'll say, okay, that's coming from this direction, and it seems to be going on all the time, it can interfere with other signals and signs that come in that same sound frequency range, and that can throw them off a whole lot as well. But when we take fish that have been in captivity and put them back in the wild, they don't know what to do. They can move fine oftentimes, but they don't respond to the sounds that go on in the wild even anymore. So when they re-released Oscars and angelfish that had been in captivity and been exposed to the sounds of a fish room or an aquarium lab, they found that they actually got eaten by predators, or they weren't able to intercept food that they were trying to eat at absolutely huge rates, something like 80 or 90% misses when they were trying to catch something to eat, and also getting eaten extremely fast afterwards. So while all this is good to know for hatcheries and things, where does it leave us with that question about, should we allow our fish to be listening to loud music? Well, first of all is going to be the decibels. You want to keep the decibels at a reasonable level. Keep them under, say, 40, and you're probably going to be fine, especially because it drops down underwater. Now, the hertz or frequency, you ideally just don't want loud random noises happening. So yeah, maybe don't vacuum right next to your aquarium. And yeah, maybe the impact is going to be that they won't spawn for you in your aquarium, or that they're a little more stressed and they release stress hormones, and that impedes their immunity and their immune function. But in the long run, those things add up. And even though they may not need to hunt for their food the same way in captivity, I think we still want to give them the best life possible. Thank you so much, you guys, for making it to the end of the video. I really appreciate it, and I hope you enjoyed the video. I assume you enjoyed the video. You made it to the end. So, isn't that fascinating about the impact that sound has on fish, on our fish? I found it absolutely, surprising that the low intensity, low frequency stuff was the most stressful. It makes sense because this low frequency, low intensity cat that's meowing right now is the most stressful for me. She's driving me insane, as you can hear. So, in any case, I'm going to let her out, and I will see you guys next time. Thank you so much for watching and supporting the channel. It means the world to me. Come here, you little bugger. Come on. Alright, you guys, have a good one. Silky says goodbye.